Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a cutting counter. So this is going to be a counter where we can place an object, like for example a tomato, and after doing a secondary interaction we can slice it. However, before we do that, let's just fix one slightly annoying issue. So right now the player is walking around, okay, that's great, I can approach a counter and interact with it, that's great. However, if I approach a counter from the side, look how the player is pointing towards the right, and if I press the double key, I can indeed select it, but the player does not rotate to face the counter. So that's just a minor visual issue, but still I'd like to fix it, so let's do that very quickly. Basically the issue is over here on our player script, so we scroll down and find our handle movement function, okay. So here we were doing a bunch of capsule casts in order to fix the problem with the diagonal movement. So you try to move in one direction, if not, try to move in just one of those. And if we can move, then we assign the move direction and then move it. Basically the problem that we have here is that if I press W to face towards the counter, then over here when we do this logic, so it's going to first attempt the X movement only, and the X is going to be 0, so the move there X is going to be 0, 0, 0, so it won't actually move anywhere, which means it won't be able to move. So this one becomes true, which then sets the move direction to 0, 0, 0, which then down here when we have our rotation, it's not actually going to rotate to anything. So we want the player to still not go through any objects, but we only want to modify the move there over here if we actually move in any of these directions. So the solution is actually super simple. So over here for the can move, we can move if there's nothing on there, and if the move direction.x is not 0. So that's really it. If we are attempting to move in the X at all, and if there's nothing on there, then we can move, which means we then assign the move direction. If not, then we don't touch this. And same thing down here. So we can move if there's nothing on it, and if the move there.z is not 0. So that's it, just this one simple change, and now the player should be able to rotate. So here we are, and if I look over there, and the player is currently looking to the left, and if I press W to point towards the container counter, and if there you go, the player does rotate a little bit. So that feels a bit more natural. Alright, so that's just a tiny visual thing that I wanted to fix, okay, so let's keep going. Now let's handle the actual cutting counter. So first of all, as usual, let's make a counter variant. So let's right click on the base counter, create a new prefab variant, call it the cutting counter. Let's go inside of it. And over here, first thing we need is the visual. So let's pick up from the assets the cutting counter visual. So here it is. Then we need the selected. So let's duplicate this one. Let's rename this one to selected. And on the animator, let's get rid of it. And instead add the component, the selected counter visual. Okay, great. Now let's drag the visuals for the visual game object array. And by the way, here's a quick tip. On the right side on the inspector, you can see this nice little lock icon. So if you click on it, then that means this inspector will not change as you select other objects. So I can click on and select something different, and this one does not change. It is still showing the selected object. Now this is useful when you want, for example, to drag multiple things. So you can lock the inspector, then the hierarchy, you can use shift click to select multiple objects, and then just drag them all directly inside the array. That's it, just a nice quick tip. So everything is done, let's unlock it, there it is. Okay, so that's it, let's just assign the selected material. So the counter selected material, let's make it just 1% bigger. So let's select them all, 1.01, okay. And let's start with all of them disabled. Okay, so the basic setup is done. Now let's make our script to run this. So let's go down, let's create a brand new C# script for the cutting counter. Let's select the parent game object and attach the cutting counter, and let's open. Now here, as usual, instead of all this, let's start off by extending the base counter, okay? Once again, thanks to how we set things up using such clean code, this is pretty much all we need to make a counter. With this, the counter already works as a counter. Then next thing we need is to customize any logic specific to this counter by just overriding the interact function. So that's it. Now over here we can put whatever logic we want just for the cutting counter. And for this one, for starters, it's actually going to be just like the empty counter, meaning we're going to be able to drop objects on this. So let's just go directly into the clear counter. So here it is. And let's just copy all of this code, go into the cutting counter and paste it. Okay, so the exact same logic. So checks if there's a kitchen object or not, checks if the player is carrying something or not, and picks up or drops it. With this, let's do a quick test just to make sure this one is working exactly like the clear counter. So over here, let's just make sure to drag the last references. So on the cutting counter, let's make sure to drag the counter top point. So drag that reference. And then on the selected, drag the cutting counter reference. Okay, everything is good. Let's exit this prefab, make sure to save all the changes. And over here in the scene view, let's place one of our cutting counters. So let's place them right in there. Let's put it on X of 4.5, 0, and 3.5. Okay, so let's test. All right, so here we are. Now if I approach and I interact, nope, nothing happens. Okay, great. Pick up some cheese and drop it on there. And yep, there it is. I can pick it up. I can pick up some bread, drop it, and yep, everything works. Okay, so far so good. Now the next goal is to use the knife and actually slice the object that is on there. And for that, the first thing that we need is we're going to need a different input. Right now, we only have the movement and the interaction, so let's add another alt interaction. For that, let's go into our input action, so let's open it up. And over here, let's make another action. So create a new action, call it interact alternate. And for the binding, let's put it on another key. So let's listen, and I think on F makes sense. So let's go ahead, select this one. Then, as usual, let's make sure to save the asset, which in turn is going to generate the C# class and compile the code. Okay, great. Now we can go here into our game input class, and let's do the exact same thing we did for the interact action. So first of all, let's listen to it. So let's go inside the player input actions, inside the player action map. So this one is the interact alternate, and let's listen to the performed event. Okay, and when we have that, let's fire off an event, pretty much the same thing. So interact alternate action. And down here, let's just fire off this event. So let's invoke using this and event args.empty. Okay, so we have the input for the interact alternate. Now let's go on the player to listen the same way we were listening to the regular interact action. So over here on the player script, let's see how we're doing things. So we go into game input and listen to that. So let's do the same thing, game input and on interact alternate action. Let's listen to this one. And when this one happens, let's do pretty much exactly the same thing, except we're just going to call a different function. So instead of interact, let's call interact alternate, which in turn obviously means we need to define this function. So let's go into our base counter. So here we are on the base counter, we've got the interact, and let's make another one exactly the same, just a different name, interact alternate. Okay, that's it. And now we are only going to implement this in the ones that need implementation. So for example, on the cutting counter, over here, let's override that one. So public override, and let's override the interact alternate. And now here, let's check if there's something placed on here. So if there's a kitchen object placed on this counter, if so, then let's basically cut it. And for cutting it, the simplest way is really to destroy whatever object is on there and just spawn the slice object. So let's handle destroying a kitchen object. For handling that, let's go over here on the kitchen object script. And let's make a simple function for this object to destroy itself. So let's go up here, make it public, return void. And for the name, I like to use the name destroy self to make it destroy this object. And really all we need to do is just destroy and call destroy on this game object. However, before we do, let's make sure to clear the parent. So let's go into the kitchen object parent, clear it, and then destroy the game object. Okay, that's great. It's really this simple. And then on the cutting counter, let's get the kitchen object that is on here and tell it to destroy itself. Okay, so that destroys the object. And after we do, let's just spawn the slices object. So for now, just keep things simple. Let's make a direct reference up here. So let's make a serialized field. Let's make it of type kitchen object SO, and for the cut kitchen object SO. Okay, so we have this. Then here in the editor, let's make sure to drag the reference. So let's go inside the cutting counter. Let's open up the prefab, and inside, let's assign this one. That means we need to create the object. So let's actually do that first. So let's create a brand new kitchen object SO. Let's call it for the tomato slices. Then if we do this, we need to create the prefab. So let's once again do the same thing. Tomato slices, make the prefab. Let's go inside this prefab. Let's modify the visual. So use the tomato slices visual. Okay, and drag the reference for the other kitchen object for the tomato slices. Okay, so the visual prefab is good. And let's just go into the kitchen object. Let's just make sure to drag the prefab reference. Then let's assign the tomato slices icon and just call it tomato slices. Okay, so we have the kitchen object SO. Now we can go into the kitchen cutting counter. And over here, let's open up and set this one to the tomato slices. Okay, so we have all the references. Let's go back outside, save it. And back over here in our code, so we have this, now we just need to spawn this object. So we're really just going to spawn it pretty much exactly like we did over here on the container. So we just go into the scriptable object, spawn the prefab, and set the parent. So let's do exactly that. Over here, we destroy the object. Then we instantiate the cut kitchen object. And instead of getting into the player, let's put it on this. Okay, so that's it. We should be able to place a tomato directly on top of the cutting counter, and it should be able to transform from a tomato into a tomato slices. Okay, so here we are. Let me pick up a tomato, go up there, drop it, and okay, that works. Now if I press the Alt Interact key, press it, and yep, there you go, it did work. The tomato was destroyed, and the tomato slices were spawned, and now I can pick them up, place them anywhere, and yep, everything works. Alright, awesome. So with this, the basics are fully working. Let's just briefly clean up this code. We already saw a little bit of code duplication. So the cutting counter is going to spawn an object, and the container counter is also spawning an object. So we're copy pasting these two lines of code in multiple places. So instead of doing that, let's put it in just one place. And actually a good place to put this is on the kitchen object class itself. So it makes sense that this one is responsible for spawning more objects. So let's put it over here. However, let us not make it a regular function. Instead, let us make it a static function. Again, just like we saw for the singletons, by making it static, it means that the function is going to belong to the class itself as opposed to any instance. So let's go all the way down to the bottom of the file. Personally, I like to put statics at the end. And over here, let's make public, make it static. We're going to return a kitchen object, and let's call it just spawn kitchen object. And for our parameters, let's receive the kitchen object SO. And let's also receive the kitchen object parent. Okay, so that's it. And we're going to do the exact same thing. So let's go into the cutting counter and copy the code that we were using. And over here, just paste it in there. So we go inside here, spawn the prefab, and set it on this parent. And finally, let's return it. So let's return the kitchen object. Over here, let's pick it up. So the kitchen object, we get it. And then we do kitchen object, set the parent. And finally, we return the kitchen object. All right, so that's it. Here we have a super simple function that we can call very easily. It will automatically spawn an object and set the parent. So now let's just call this from somewhere. So over here on the cutting counter, instead of doing all this, let's just go into the kitchen object. Again, remember, let's go through the class name itself and not any instance. And over here, let's call the function, pass in the cut kitchen object SO, and for the parent, it's going to be this. All right, so that is now much, much simpler. And let's do the same thing over here on the container counter. So if the player is not carrying anything, let's give the player this object and give it to the player, just like this. As usual, when we do some kind of refactoring, let's do a quick test to make sure everything still works exactly the same. Okay, so here we are, and if I go to the counter and pick it up, yep, it does work, does spawn the object. Now I can drop it in there, I can cut it, and yep, there you go, everything does work. All right, so far so good. So with all of this, basically we have created a brand new counter where we can cut objects. However, right now there's obviously one huge glaring flaw. If I now pick up a cabbage and I drop it on the cutting counter and I interact with it, that cabbage has suddenly magically turned into tomato slices. Now that is obviously not intended. So for that, let's define a proper cutting recipe, and let's do that in the next lecture.